Hey, what's going on, guys? Games here. In this video we'll finally start moving our pieces. So let's get to the very end of our source code. I also want to open the terminal in the current working directory, and by typing make I just compile the source, and if it compiles I just want to run the binary executable called chess hexadecimal 88 produced by the compiler. Okay, so this is the output from the previous series, from the previous episode. And let's go to our MakeMove function just right over in here. So the very first thing to consider, the most simple thing to do is actually to move the piece from the source square to the target square. So move piece, placeholder here. But in order to move the piece, first we need to extract the from square and the to square from the move. So extract source and target squares from encoded move. So you remember, like, we're storing our moves within the integers, so I'll now provide a little test within our main function here in order to provide this sort of a stuff. So I just want to create integer from square variable, and this would be equal to let me just recall my memory to remember how we call this macro. So get move source, get move target. Okay, so this macro get move source allows us to decode the integer that is taken as an argument by the MakeMove function in order to extract the first 7 bits out of it that encode the source square, and move as an argument here. And we also need to create to square, and this would be equal to get move target, and this macro would allow us to extract the next 7 bits followed by the first 7 bits to extract the target square being encoded there. So this was explained in great details in the video dedicated to move encoding and decoding, so please feel free to check that video out within this hexadecimal 88 chess engine series. Okay, and well, first let's actually try to print the move to make sure it kind of works. So I want to print 2 strings, so I'll use my square to coordinates array indexed by from square. That would be the actual index square, and the same for the to square, for the target square. Paste. And here we can simply say like move and these two values here. Now we need to quickly encode the move, so say create move and int move. It would be equal to, now we would be using the set move macro that allows us to encode moves. So we need to say, like, let's say, so depending on the board position, so we have this tricky position. Let me just try to compile and run to see like what we're supposed to be moving here. So let's assume that we would have been moving our pawn from d5 to d6. Well, actually we can move whatever piece, it doesn't really matter that much. And this move piece part would move the king to the g1 square in case of castling as well, and literally all the moves, and the pawn, 1 ahead pawn moves, the two square ahead pawn moves, so literally all the available moves generated by the move generator. So it doesn't really matter that much what particular piece to take, but I just want to take this d5 and d6. So set move, so the source square is d5, target square is d6, Promoted piece is not available, so 0 there. So capture flag is 0. What was going next? In peasant. Pawn start, double pawn push flag is false. And in peasant capture, it's not in peasant and it's not castling. So this again, like these flags have been just provided here, are explained within the encoding and decoding moves video in this series. So just to give you an idea, so if I just print the move as a decimal number, so say move, and just to provide this decimal number for it, it won't really tell you that much basically. So I can simply print the move like this. So oh my god, what's gonna run here? Add move, oh, not set move, and not add move. I mean, I'm sorry, I meant encode move. Yeah, just the wrong name for a macro. So this is the integer representing the move d5 to d6 and all the flags set to 0. And this doesn't really make much sense, so we need to decode this, and that's the exact thing that we're doing right over in here. Get move source, get move target, square. So now we can already make use of this move in order to pass this to the MakeMove function. So actually MakeMove, finally. So MakeMove would take this move as an argument. Let's see, now I suppose that we should see this d5 and d6 coordinates being printed. So yeah, we got these coordinates being extracted, so the from square already converted to the human readable coordinates like d5 and the d6. So the very last thing left here, in order to move the piece, we actually need to set the target square equal to the content of the source square and then reset the source square. That's it, quite pretty simple. So let's actually go for this. I don't really want to print this decoded squares anymore because we don't really need that. Instead, I want to say board indexed by the 2 square, or by the target square, would be equal to board indexed by the from square. Okay, and then we can say board indexed by the from square. So after the piece is moved, it's kind of like duplicated, right? Well, let me just demonstrate you this. It's not a big deal really, so why not to demonstrate? So MakeMove, and I just want to print board after the move is made. Save. So okay, now you see, like we did duplicate this pawn, and the next, so this is the first part of moving the piece, so the next part would be to reset this guy here. So we literally need to say like board indexed by the from square would be equal to E, that stands for empty square. We could have also used 0 here, but I just encoded this E like the empty square. So if you just have a look again, you see like it seems like the pawn has just moved. Okay, perfect. And one little more thing, because before we end this video, I just want to provide one more little driver here. It's a test driver that would allow us to preserve and to restore the board position. So we'll make use of exactly the code being used right over in here. So it's used twice within the MakeMove function, and just to distinguish between the cases if the move is legal, when the king is not exposed to check, and when it is exposed to check, it's not legal move. And but that's the special case. Well, the common case would be the following one. So we just before making a move, we preserving the board state. So we're creating the variables that just would store the copy for the board position, for the king squares, side to move, and peasant square, and castling rights. Then we copying them, okay, and then we make the move, and then we print the board, okay, and then we need to restore it back. So I can simply say like, just want to restore it back here, and yeah, and after I restore it, I just want to print board one more time to make sure that the board position and the entire board state has been changed. Well, if we're talking about just moving pieces, it's not really that essential, but in the next videos we're supposed to be debugging things like altering the in peasant square, like castling rights and things like that. So it would be incredibly important to check that everything is changed appropriately and restored appropriately as well. Otherwise, it's gonna end with a complete disaster with the perf test that we won't pass ever. So I hold my breath and try to compile and run this again, and let's have a look. So we got our initial board position here with a pawn on d5. Okay, then we're making this move, so pawn moves to d6. Okay, so the board state is not getting changed here. So yeah, we will also need to change the side, but I will implement this later on, just not now. Just we'll follow all the features step by step. So side to move is not yet being changed, but it would be it would get changed differently, definitely later on. So just to bear in mind. So castling peasant square, so nothing has changed here because just the regular pawn move, not containing any flagging that we have some capture or double pawn push or in peasant move or castling or promoted piece. So none of those. And is this the current? So oh my god, I have some unnecessary. Oh, that's the terminal from the previous part. Sorry. So and after we did this move, we did restore the position and the side and castling, so everything seems to be just restored here, and this pawn has returned back from d6 back to d5. Well, this is it for this video, guys. I hope you learned something interesting out of it, and now you understand what a great idea is to use this board state preservation and restoring after. It takes a little bit of a code, but it's much less compared to if we will write the full-blown take back functions. So this is kind of it. Well, thanks for watching. Hope you've enjoyed this video. So until the next time, and take care.